everybody! In this video I will show you how to crack passwords in Windows 11. And before we start, please note that you can only crack passwords on your personal computers that you own, otherwise it's a felony and you'd be committing a crime. The following information is for education purposes only, thank you. The natural question is, why would anyone crack a password in Windows when it's so easy to force yourself into it without knowing the password? Now here's the deal, you never get to know the password. Sure, you reset it, but the old password remains unknown to you. What I'm doing here is not showing yet another way to bypass the Windows authentication mechanism, but instead compromise it and acquire the password. Hope it makes sense. I'll give you a quick introduction into passwords. Basically, nobody stores passwords in plain text. I mean, Windows does, but we don't talk about that. Nowadays, the passwords are always hashed. Perhaps you've heard the word hashing before. If you're unfamiliar, here's a quick explanation. A hash function is a one-way mathematical function that translates strings into fixed-length gibberish. One-way meaning the gibberish cannot be translated back into the original string, even if you know the algorithm. The output of a hash function must be unique, meaning there should not be collisions. Say there is one string that translates into certain gibberish. If there exists another string that also translates into that gibberish, the hash function contains collisions and is considered compromised. For example, a modern hashing function, modified SHA-256, was practically compromised half a year ago. It was modified to have 31 encryption rounds, and even though SHA-256 has 64 rounds by design, it's solid progress in cracking the entire hash function. Don't worry though, it gets exponentially harder to find collisions with each round. Collisions are a problem because you need one-to-one correspondence between the password and the gibberish. If a collision is found, the authenticity of the hashed password is lost. That means you can create another password that results in the same hash. Bitcoin uses SHA-256, so these are rather big news. Anyway, your password is converted into gibberish, and since it's a one-way function, the hash is calculated every time you log into the system. That ensures your password is kept safe from the attackers, even in the event of a breach. However, that's not enough. The computation and storage powers grew significantly over the past 20 years, which allowed attackers to consolidate and pre-compute hashes to store alongside the plaintext passwords. Hash databases exist, and they're used in dictionary and rainbow table attacks. Both attacks are using pre-computed lookup tables to quickly crack the passwords by just looking up the hash in the database. In turn, this can be prevented by salting the hash. That means adding random strings into passwords before hashing them. The string called salt must be random for each user, otherwise targeted lookup tables, aka hash databases, can be generated specifically for your system. This is a common mistake in cybersecurity, and you can avoid it now. A grave mistake would be to not use salt at all, which would allow attackers to use huge pre-computed hash databases for a certain hash function your system uses. Guess what Microsoft did? In short, your local Windows password is stored as an unsalted MD4 hash. The MD4 function was published in October of 1990. The first full collision attack against MD4 was published in 1995. And Windows 11 was released on October 5th, 2021. This begs the question, what the f*** Microsoft? I mean, sure, MD4 may be used in this case, it's not a sensitive system, but the hash is unsalted. Somebody ignored the basics of cybersecurity. That means we can freely use pre-computed MD4 hash databases to crack the password at no cost. The MD4 being compromised also means there is almost certainly a collision for your password, meaning there could be a second or even a third password to your Windows account you're not even aware of. This sucks. The hashing algorithm has not been updated since 1990s. Have some respect, at least use MD5 or MD6 if you're feeling quirky. Or even better, just use modern alternatives like bcrypt. Run 12 rounds of that puppy and you're good to go. Nobody at Microsoft cares though. So let's dive into this. If you haven't seen my previous video where I showed Microsoft storing your Windows security questions in plain text, I suggest you giving it a watch. Windows hashes are terrible. However, Microsoft encrypt them using AES in newer Windows versions. Older versions use an elaborate algorithm utilizing MD5 and RC4. Nothing I mentioned above, however, makes it any more secure, because the decryption key is also stored locally and available after a little bit of a headache. I'll target newer versions first, including the latest release of Windows 11. First of all, every Windows machine has a so-called LSA key that's used to decrypt the AES encrypted boot key. The decrypted boot key is then used to decrypt the hashes. But wait, Enderman, you only talked about a single unsalted MD4 hash. Windows actually has two hashes in the Security Account Manager. They're called LM and NTLM respectively. LM stands for LAN Manager, and NT stands for New Technology. The one I was talking about is an NTLM hash, otherwise known as an NT hash, and Microsoft prefers to call it NT hash, so let's define the NTLM hash as an NT hash and call it a day. I didn't mention the LM hash because it's complete garbage and not worth blabbering about for the sake of this video. Microsoft themselves abolished the LM hash since Windows Vista, and for a good reason. Even before Windows Vista, you could turn it off via the registry. We'll talk about it in a video where I target older Windows versions. The only locally available hash in Windows that's used currently is an NT hash, which again is simply an unsalted MD4 hash. So, after we decrypt the boot key using the LSA key, we have to decrypt the hashes using that boot key. Once that's done, we have to decrypt the decrypted hashes again, because they consist of two 8-byte parts encrypted using DES with a user key for each part. What is a user key? It's a user relative ID represented as a 32-bit little endian integer, shuffled in the right way, shuffled again in the right way, masked in the right way, and then converted into magic 8 bytes. That's why I call them deobfuscation keys. This algorithm is hard-coded and strictly defined within Windows. The only use for these keys is to increase the reverse engineering complexity of the Windows code, with a background task of allowing different users to have the same passwords without a matching hash. Once the user keys are calculated, we can finally decrypt the decrypted hash using DES in ECB mode to get the NT hash for the user's password. The technical part is over, but things get more interesting once you begin searching for the LSA key. The key is actually split across the Windows registry, and the values are unusually difficult to find. If you think you have decent knowledge and feel for Windows registry, what I'm about to show you is most definitely gonna surprise you. Okay, the LSA boot key is split into four 4-byte chunks. To get them, we need to first navigate to HKey local machine system current control set control LSA. We are interested in 4 subkeys, namely JD, SKU1, GBG, and data. These subkeys contain values stored in a binary format, and they look like exactly what we need. Since we're trying to restore an LSA key, we just need to concatenate the bytes. Those look like bytes, right? Actually, this isn't what we're looking for, and I'll tell you what, these values are likely a red herring. Because the LSA key chunks are stored directly in the subkeys. But the registry keys are like folders, how can you store data directly in them besides naming them something? Well, actually, did you know registry keys have class names attached to them, and you can store data in the class names? I was flabbergasted. There is no way to view that anywhere in the registry editor. There is no such functionality in that official Microsoft tool. It's never shown in the registry export. There is no syntax for that in the reg file. Actually, there is a way. I lied to you. Remember this? The print option within the registry editor. Why would anyone use that? Nobody wants to print a registry tree. This is useless. Let's go ahead and print out the JD key. I'll print it as a PDF file. Huh. What's that? A class name. And it's 4 bytes long. Here's the value. Here's the key name. But there's the odd man's out. A class name. What is it doing in here? I wonder why you can't view that normally through the registry editor. It's as if someone tried to hide something from me. Anyway, we'll need these values to compose the LSA key in order to decrypt the hashes residing in the security account manager. We have to print each one of these values as PDF and copy the class names, and then pass them as arguments into my script. That's the most difficult part I've encountered, and I actually learned something new about Windows Registry. It's impressive. The remaining data is stored under the SAM hive. We will need the general value F under account. It contains a couple values, but most importantly, the encrypted boot key resides there, and the V values for each user. They contain both hashes and useful information about the accounts. For example, the full name of the account owner, the logon script path, and so on. It's all extracted automatically in my script. We just have to export the SAM reg file and pass the path to that file as an argument. So let's give it a go and fill the data in. Beautiful. Run the script. There is no LM hash, but there is a decrypted NT hash. That's exactly what we need to crack the password. As I mentioned before, it's a simple unsalted MD4 hash, so we can run it against a hash database. I'll use CrackStation.net to look up the password via the hash. That's just an example, and it wouldn't have been possible had Microsoft salted the passwords before hashing them. Voila! This isn't a particularly strong password, but we've cracked it. It's 9988. I said it in the previous episode, so I can vouch it's probably correct. Let's go ahead and try it out. It works. Ladies and gentlemen, this is how you crack the password in Windows 11. Again, you're not allowed to crack passwords on the computers you don't personally own. If the dictionary attack does not work, it's pretty easy to run a mask attack on your GPU using Hashcat. It supports both LM and NT hashes. Great software all around, and more importantly, it's free. Alright, that should be it for the video. Keep your passwords safe. Share this video with friends to let them know their passwords are stored as unsalted MD4. Thank you for tuning in to your favorite show without a schedule called Windows is Complete Garbage. It was your host Enderman. Take care.